Hello everyone, I am Dr. Parvez Ahmad. Today I am going to talk about the mechanism of action of digitalis. What is the example of digitalis? Digoxin and digitoxin is the example of digitalis. And these categories of the drug act on heart, that's why also called cardiac glycoside. Now the mechanism of action. During the depolarization at SA node, the 1% of the calcium enter into the cardiac cell via the L type of calcium channel. This 1% of the calcium activate the RYR2, that is ryanodine receptor. Once this receptor RYR2 is activated, this stimulate or catalyze the massive release of stored calcium in the sarcoplasmic reticulum. Now, the excess and abundant amount of the calcium present in the cytoplasm of the cells, which activate the troponin C, and finally actin and myosin interaction takes place, and finally contraction occurs. These are the mechanism of actions. Okay, but after the systole, after the contraction, 99% of the calcium again taken back by the SARCA2. That means the sarcoplasmic reticulum calcium ATPase channels, and again stored in the sarcoplasmic reticulum. And then 1% of the calcium now move and try to going outside. The 1% calcium removed by the sodium calcium exchanger and exchange with the sodium ions. Now this sodium ion again remove from the cell to the outside with the exchange of the potassium via the sodium potassium ATPase. And now the diastole relaxation occurs. So these are the normal physiology of the heart contractions and relaxation. Now the mechanism of action. First to understand here what is the role of the sodium potassium ATPase channel. First you understand here different type of the channel which are present at the surface of the cell. Here sodium potassium ATPase. Second one is the sodium calcium exchanger. Now what is the normal function of the sodium potassium ATPase? These are the channel which remove the sodium from the cell and bring the potassium from outside the cells. So these are the normal function of the sodium potassium ATPase. Now the digoxin, mechanism of the action of digoxin. Digoxin, which inhibit the sodium potassium ATPase enzyme channel. Once this enzyme is inhibited, excess amount of the sodium present inside the cell. That means that this sodium is unable to go out. And now gradually accumulation of the sodium ion inside the cell. And this excess amount of the sodium inhibit the sodium calcium exchanger. Now come to the point again. During the depolarization, 1% of the calcium is entered in via the L type of the calcium channel. This 1% of the calcium again stimulate the ryanodine receptor, and once the ryanodine receptor is activated, this stimulate the uh, and help the release of the massive calcium from the sarcoplasmic reticulum. Now the here excess or abundant amount of the calcium which are present in cytoplasm, which activate the troponin C and actin myosin interaction takes place, and finally heart contraction occurs. Okay, now 99 after the contraction, after the systole, now 99% of the calcium now again taken back by the SARCA2 and stored here and sarcoplasmic reticulum. Now 1% of the calcium again try to move to go outside from the cell. But we know that here digoxin inhibit the sodium potassium ATPase channel. This sodium ATPase causes excess amount intracellularly sodium ions is high. This sodium ions inhibit the sodium calcium exchanger. Now the 1% calcium unable to move out from the cells. Now this calcium ion again come to the ryanodine receptor and activate them, and then massive release of the calcium from the sarcoplasmic reticulum, from the sarcoplasm to the cytoplasm of the cells. Now again activate the actin and myosin. Now contraction takes place. Now after that again 99% of the calcium again taken back by the SERCA2, and 1% of the calcium is still in a cytoplasm. Now 1% of the calcium again try to move from the cell to the outside, but we know that sodium calcium exchanger is inhibited by the sodium, because we have already inhibited sodium potassium ATPase by the digox. Now again 1% calcium again come to the sarcoplasmic reticulum and activate the ryanodine receptor. Again same story, again massive amount of calcium released from the sarcoplasm to the cytoplasm of the cells. Again activate the actin and myosin, and contraction takes place. And this story is repeating now systole and systole. These are the mechanism of action of digoxin. Now move to the next slides in easy way. See the here cardiac glycoside, that is digoxin digitoxin or digitalis, which inhibit the sodium potassium ATPase enzyme. And after the inhibition of this enzyme, this channel increase the concentration of the sodium inside the cell. That is increase the intercellular sodium, and which inhibit the sodium calcium exchanger, and finally increase the level of the calcium inside the cell. Now the contraction occurs. So these are the mechanism of action of digitalis. Thank you all of you.